Hey guys, here's your guys' lecture video on remainder theorem and factor theorem. Okay, so the learning goal today is students will be able to find the remainder and factors of a polynomial using the remainder / factor theorems. Okay, so this is what the remainder theorem states, you guys. When a polynomial f of x is divided by some polynomial x minus a, the remainder is f of a. So find the remainder when 2x cubed plus 3x squared minus 17x minus 30 is divided by each of the following. So in order to find the remainder, you guys, all you have to do is, if you have a linear binomial, all you have to do is you have to substitute the opposite of that number into the function, and that will enable you to find your remainder. So if we did part A, right, so this is all divided by x minus 1. What we can do to find the remainder is to substitute in 1, you guys, into the function, because 1 is the opposite of negative 1. And if you guys do that, everywhere you see an x, it is now a 1. We would get 2 plus 3 minus 17 minus 30, which is negative 42. And that would be your guys' remainder. Now, if you guys did this for every single problem, you would also find the remainder as well. So if you substitute in 2 into this one, because right, you guys, the opposite of negative 2 is 2. Plug in 2 into that equation, and you would also get, let me see, if you simplify this, you guys would get negative 36, and then so on. So you guys just substitute in the opposite number, and you guys would find the remainder. For this one, if you guys plugged in 3 into that equation, you would realize that you would get a 0, I believe. 54, 27, minus 51 minus 30, and yes, you guys would get 0. So as you guys can see, if you guys just plug these in into the function, then the opposite of these numbers, then you would get 0. So for this one, if you guys, if you plug in negative 1 into here, you would get a certain remainder. Negative 2 plus 3 plus 17 minus 30, negative 12. This one here, you guys, plug in negative 2 into the function. So remainder theorem is not that challenging. It's just, as you guys can see, it's just a lot of plugging in into the original to finding your value. So that's 0, and one more. If you guys plug in negative 3 into the function, everywhere you see an x, it is this part. You guys would get negative 54 plus 27 plus 51 plus 30, negative 6. So those are all of the remainders, okay? Those are all the remainders from A through F. Now, if you guys did your factor theorem, this states if x equals a is substituted into the polynomial for x, and the remainder is 0, then x minus a is a factor of the polynomial. So for example, do you guys see how for every single one of these problems we plugged in the opposite of the number for each one of these, right? And when we plugged in all of these, you guys, did any of the remainders, were they 0? And there were, right? There was 2 of them. Part C gave us a remainder of 0, and part E. So part C and part E, you guys, those both gave us a 0, and I'll make sure I'll clean that up so you guys know that's a 0. Both of these gave you a 0, which means, you guys, x plus 2 and x minus 3, those would be considered factors of this polynomial because we found a remainder of 0 for both of those. So, using the above theorem, your results from question 1, which of the given polynomials are factors of that? It is x minus 3, right? Because there was a remainder of 0, and it was x plus 2, because that also gave us a remainder of 0. Number 3, using the binomials you determine were factors, which were those two, complete the division, which is divide 2x to the third plus 3x squared minus 17x minus 30 by your chosen x minus a, and remember to fully factor your result in each case. So right now we are going to factor this out, and we're going to factor this using the fact that these are factors. So if those are our factors, then that means when we use the zeros of these, then we can find, if we use the zeros of these, then these will produce a factor from here by using synthetic division. So if we use this first factor, you guys, and use it synthetic division with that, the opposite of negative 3 is 3. And we got 2, 3, negative 17, and negative 30. So we do synthetic division, and then 2 times 3 is 6, 6 plus 3 is 9, 9 times 3 is 27, 27 times negative 17 is 10, 10 times 3 is 30, and we get a 0. Which makes sense because if we get a remainder of 0, you guys, that means that this was a 0 and this was a factor. Anytime we have a remainder of 0, that lets you guys know that we have a factor. We also had this though, right? That was another one of our factors. So if we use this now with this using synthetic division, we can find our other factor. Negative 2 times 2, you guys, is negative 4. Negative 4 times 9, you guys, is 5. 5 times negative 2, you guys, is negative 10. 10 times negative 2 is 0. So that makes sense because, right, this is a factor, you guys, which means it should give us a remainder of 0. Now, how do we know what this polynomial is? Remember, it's 1 less than this degree. So if that's x to the third, this is x to the second, and that is x. Now, didn't we get this one, you guys, from this one, right? So what's 1 less than this? 1 less than x squared, you guys, is x. So our factors are x minus 3, x plus 2, and 2x plus 5. And those are all of our factors. So do you guys see how we can use synthetic division in dual with our factors to find other factors of a polynomial, right? So that is how you guys go about that. Okay, now let's flip over. Okay, quick thing to recognize with this, you guys. Factors look like this. Okay? And you also could find zeros from factors, right? Because to find your 0, you guys, don't you guys just plug in negative 2 into that to get a 0, right? Negative 2 plus 2, you guys, is 0. So you guys, hypothetically, you could get your zeros from factors. Is that also true the other way around? If you guys had a 0, can you guys get your factor? And you can. Your factor would be x minus 3. So if you guys have zeros, you can get the factors, but if you have factors, then you guys can also get your zeros. So, for example, 8. Now, this one wants you guys to compare synthetic and your guys' remainder theorem. So, from remainder theorem, you guys, you know you just gotta plug in that number into all of these, right? You just plug in -4 everywhere you guys see an x value. Now once you guys do this, 3 times -64 plus 64 plus 20 plus 7. -64 times 3, you guys, is -192 plus 64 plus 20 plus 7, which is -101. So that was doing that through remainder theorem. Now watch when you guys use synthetic division through this. -4, coefficients of 3, 4, -5, and 7. 3 times -4 is -12, add -8, -8 times -4, 32, add -27, -27 times -4, that's positive 27. So that's going to be -108, and -108, you guys, plus 7 is -101. Do you guys notice anything? Aren't these the same? So, in order to find your guys' remainder, you could also use synthetic division. You could do either of the two, and both of them are important for when we do rational root theorem in the end. But just remember, you can use either synthetic division to find your remainder, or you guys can use the remainder theorem to find your guys' remainder. They're both the same. So all of this stuff, you guys, that we did up here, hypothetically, you could have done synthetic division as well. And if you get a remainder, that's not a factor. If the remainder is 0, that's a factor. Now lastly, for example 9, this is a challenging problem, and it's good for you guys to get exposed to this first before we get off to rational root theorem. So this says solve the equation for this polynomial given that -2 is 0 of that polynomial. So whenever it says solve the equation, you guys, you know you have to solve for x equals 2. X gotta equal to something. Another thing, do you guys see how they gave us a -2 as a 0? So if they gave us -2 as a 0, you guys, that means x equals -2, and we also know that x plus 2 is a factor. So if we have this factor, right, and this 0 knowledge, we can use synthetic division to find the other factors of this polynomial. So -2, 2, -3, -11, and 6. And since we know this to be a 0, you guys, if we find the remainder of this, it should be 0. 2 times -2, -4, add, -7. -7 times -2, 14, add, 3. 3 times -2, -6, add, it's a 0. And what are the degrees of this? Well, the degree of this one's x to the third, you guys, so this is going to be 1 less, and 1 less. So we have a factor of x plus 2, and we have a factor of 2x squared minus 7x plus 3. Now, how do we solve for this? Well, we know this is x equals -2, you guys, because that's literally what it told us, right? But how do we factor this? Or how do we find those zeros? You gotta use your guys' factoring a is greater than 1. If you guys forgot, a times c is 6, b is -7. Two numbers that multiply to 6, but when added together gives you -7 is -6 and -1. A is greater than 1, which means you guys got to factor by grouping the first term, the two middle terms, and the last term. Group, factor out a 2x from both to get x minus 3, factor out a -1 from both to get x minus 3. And we get 2x minus 1 times x minus 3, and don't forget the x plus 2 we had in the beginning. A 0 of -2, a 0 of 3. This one, because there's a 2 in the front, you should probably set this equal to 0 and solve for this by manually. X is equals to 1/2. And that is how you guys find your factors. So, something that we'll definitely practice, but strap in your guys' buckles because this is where we're heading, especially when I expose you guys to rational root theorem, okay? So digest this, do the best you guys can, and we'll do a good amount of practice on this so that you guys get a better feel for it, okay? Make sure you guys write one thing you did learn today, and I suggest you definitely make sure you know if you guys get a remainder of 0, whether you use remainder theorem or synthetic division. If it's 0, that means that binomial was a factor. Okay? All right, good luck, you guys. Peace.